We are on the 11.3b worksheet. We are going to be multiplying monomials times polynomials, dealing with some exponent properties, and making sure we know what's like terms and what's not, and what can be combined and what can't be. All right, so number one, we've got two separate things we need to do. We can see we're separated here by the plus sign. So we're going to do this and this. If after we multiply, we have like terms, meaning it has the same variable with the same power, then we can combine them. But if not, they will have to stay separate. So just a quick look ahead of time, I can already see these are not going to be the same, because a c times a c will be c squared, and a c times c squared is going to be c to the third. So these will stay separate. And to save myself a step, because I'm thinking ahead, I'm actually going to start with the one that has the higher power so that my answer is in the right order. So when I multiply here, 8 times 2 is going to be 16. C times c squared, remember this is c to the first. You add the exponents when you're multiplying, that's c to the third. That will stay separate, I know, because this will be a c squared. 5 times 9 is 45. C squared. All right, next one. We're going to go ahead and distribute both of these and then see what we've got if we can combine anything. So when I multiply here, that's a 117d minus 5 times 13 is 65. Now when I distribute here, make sure that you see that this is a negative d being multiplied. So it's really just a negative 1 in front. So times the 8 will be negative 8. And a d times a d will be d squared. And now this is a negative times a negative, so that's positive. Got to be careful there. 2 times d will just be 2d. Okay, so as I look at all of these, I do have like terms here and here. Okay, they both have a d with a single power. And these do not. These are going to have to stay separate. So if I put this in the right order, negative 8 d squared is going to go first. These will go next. I'm going to combine them. They're both positive. Just add them together. 119d and the minus 65 tags on the end. All right, number 3. Distribute here. So that is 6e squared. 6 times negative 2, negative 12e, and then 8 times 6, positive 48. Plus the 7e squared, still nothing going on there. That will combine with the 6. So I'm going to have 13e squared when I put those two together. Everything else will stay separate. So minus 12e plus 48. Distributing here, I'm going to put this on the bottom so I can write up top. 3x squared to the third. 3 times negative 2, so negative 6. The x squared just goes with it. 3 times x is 3x. Negative x times here. So negative times a positive is a negative. This is x to the first times x to the second. That's x to the third. And then multiply here. That's negative x times positive 7, so negative 7x. Look for like terms. I see a couple. So first of all, starting with the x to the third, that's a 3 minus a 1. So that's a 2x to the third. Okay, those are gone. Next power would be to the second. That doesn't have anything to combine with, so we're going to stay negative 6x squared. And now my x's can combine, and they're up next. 3 minus 7 will be negative 4, so minus 4x. All right, multiplying here. Coefficient's 1, so these numbers aren't going to change. Multiplied by 1, we're just going to add the powers. So that is 8g to the 5th minus 10g to the 3rd plus 2g squared plus g to the 5th. When you multiply here, g times a negative is minus 16, and that is g to the 3rd. All right, biggest power I see here is the 5th. So I have the 5th here and the 5th here. So that's a 1, and this is an 8. So you put those together, that's a 9g to the 5th. Next would be the thirds. So when I put those together, negative 16, negative 10, that's negative 26 g to the third. And then all that's left over is that plus 2g squared. All right, distribute here. That's h to the fourth plus 7h to the third. This is a negative times all of these. Okay, so I'm going to get a negative h to the fourth. This will be a positive, negative times a negative, h to the third. And here this will be a positive. Whole number just attaches to it, 4h squared. Okay, so I have an h to the fourth and a negative h to the fourth. Those cancel. So no more powers of 4. On to the powers of 3. Put those together, 7 and a 1, that is 8h to the third. Only thing left over here is 4h squared. Okay, number 7. Going to distribute here, 3 times 2, that is 6, and the j's are j to the fourth, times 1 is just 3j to the third. Distributing here, it's a positive, so 4j add to the fourth, multiply negative 8j to the third, plus multiply 24j squared. All right, I've got a couple fourths to deal with here, right here, and right here. So that is 10j to the fourth. My thirds, I've got a 3 and a minus 8, so that's negative 5j to the third. And then I still have this plus 24j squared. All right. Fraction, multiplying by half is easy. It just takes half. So half of 8 will be 4k to the third. Half of 4 will be 2, and the k squared needs to go with it. All right, you can use your calculator if you need to for this fraction, but it is an easy fraction to deal with. We're going to distribute, and that's going to be negative. Remember, if this number divides nicely, you can do that first by the bottom number, so that's what I'm going to do. 8 divided by 2 is 4, times the 5 is 20, and the k times the k is k squared. 6 divided by 2, that's 3. Oh, first of all, this is a negative times a negative, so this is positive. 6 divided by 2 is 3, times 5 is going to be 15, and the k goes with it. So the only power of 3 I have is the 4, so that will be in my answer. And now I've got a 2 minus a 20, that's negative 18k squared. Those were k squares, that's why I put them together. And then I still have plus 15k. Okay, number 9. These now we're going to have, the reason that these are separate into a separate section here is because we're going to create terms that have more than one variable in them. All of these up here, you notice, we multiplied a bunch of stuff, but everything was just a d or just an x or just an h. Now we're going to be having more than one variable there. And so it's a lot less necessary to try and put everything into standard form. It just becomes too much. So we're just going to go ahead and multiply through, combine anything that is alike. So m times n is mn. M times p is mp. So when you're multiplying variables together, they just combine. If they're different, right? We're not going to do anything with the exponents. That's only when you multiply a variable times the same variable. These just combine. Okay, this is a negative times a positive, so negative. It's an m and an n, they just combine. So 2mn. Normally you put them in alphabetical order, so that's why I put the m up front. Negative times a negative is a positive, and it is a 3mp. So I do have some common things here. I've got an mn and an mn, so those can go together. That's a 1 minus a 2, that's negative 1, so negative 1mn. And this is a 1mp and a 3mp, so that is a 4mp. All right, nothing to multiply here, This I do, though. So 3 times this, that's 6r squared. That's negative 12rs. And that is a positive 3s squared. Now, this all comes up. And let's start combining like terms. R squareds. And again, the order that you put these in at this point when we start getting this complicated is not super important. So it is going to be 7r squared. Now, in the book, they didn't go to the squareds next. I would, just because I'm used to putting the powers up front. So I'm going to take a look and see. I have an s squared and an s squared. When you put those together, that's a 4s squared. And then these are similar, like terms, because they're both an rs. Now, if one of these was an rs and one of these was an rs squared, those would be different. Okay, but it's the exact same variables with the same exact powers. So it's 2 minus a 12, that's a negative 10rs. All right, 11 and 12, we're going to find the missing polynomial. So what was this multiplied by? It was multiplied by something to create this. So 5 times something gave me 15, that would be 3. And t squared, when it got multiplied by this, became t to the 4th. So I added 2 to it, so it was t squared. So imagine this in here. It would be a minus. And then 5 times something gave me 10, that would be 2. And t squared stayed t squared, so that means there's no t on this. All right, and you can always double check your answer on these working backwards one. Multiply 15, add t to the 4th, multiply 10, and the t squared just stays. So we're good. And now we have some fractions here. So this can be a little tricky. So 3/4 times something gives me 6. Okay, so if we're working backwards here, we're actually going to divide. So I want to know 3/4 times something is 6. So working backwards, I'm going to divide. Thinking back to here, if you get lost in that with the fraction, think back to here. If I had the 3 and the 2 and I couldn't figure out what they were, 5 times something is 15. I could have done 15 divided by 5 to get 3, or 10 divided by 5 to get the 2. So I'm going to do 6 divided by 3/4. And that's 8. Okay, so I know that this was 8, and v to the 3rd became v to the 5th, so that would be v squared. Now let's say you didn't have a fancy calculator where you could use the fraction function. You could do 6 divided by 3 divided by 4. Nope, that doesn't work. You need the parentheses there. 6 divided by 3 divided by 4. And let's say you had a calculator that didn't have the parentheses for you there. We could do 3 divided by 4. Oh, that's 0.75. So I could do 6 divided by 0.75 and also get the number. The reason that the other one didn't work, this doesn't work, is because it actually does 6 divided by 3 first and then divides by 4. It always follows that order of operations. So we got to either put that in parentheses or turn it to a decimal first. But I'm going to keep using my fraction function since I have this. So now this became a negative, so I know that I'm going to have a minus here. All right, so 9 divided by 3/4 is 12. V to the 3rd became v to the 4th, so there's a v on it. And then the last one, well, I know if I take 3/4 of something and I get 3, that's 4. You can run it through the calculator if you need to. But 3/4 of 4 is 3. Okay, so this is a positive 4, and v to the 3rd stayed v to the 3rd. And so that's going to stay there. All right, now down at the bottom, we're going to find the product, so we're going to actually multiply. So that's the easy part. Let's do that first. And then we're going to draw a rectangle to represent this. So we multiply here. It's 4a squared. Multiply here, 24a. Here, 6b squared. Multiply, 18. So when I go to represent these, I got to remember that rectangles, when I'm looking at this multiplication, it's length times width. And so I need one of the lengths or widths to be 4a. And if there's 4 of them, they're just individual a's. So I'm going to have sides here. So I'm going to keep them separate for a second just so you can see it. You don't have to draw it like this exactly. But I know that each one of these lengths is going to be an a, because this whole side here would be 4a added up. Okay, and this whole side is going to be an a plus 6. So there's going to be 1's there. So I know that I do have an a here. And so just starting with that, I know that these all are going to look like this. You can now connect them. See, the reason I didn't draw these boxes to start with is because I didn't know if this top part was going to be an a or a 1. Okay, so far I have a. I need plus 6. And so to create that, I'm going to have these little 1's. It's going to be 6 of them. 1, 2, 3, 4, 5, 6. All right, and then these, of course, will go all the way down. So you can draw these like that. Easiest way is probably just draw them all the way down. Clearly, I'm not an artist. Okay, and so you can see that this part up here is a plus 6. So a times a is a squared. Each one of these, the area of each one of these individual ones is a squared. And so there would be, for the total area, there would be 4 of these. And here's your 4a squared. And all of these, length times width, individual little boxes here, rectangles, would be a times 1, which all of these would just be a. Okay, and you could fill them all out. And you're going to have 4 rows of 6, meaning you're going to have 24 a's. And that's where this 24a comes from. So when you draw this out and you look at it, you can count up your boxes to find your area. This represents the area right here. Or we're showing that it's easier to just multiply length times width. This length is 4a, this length is a plus 6. Multiply those and you get the same answer. All right, so what about this one? So we're going to start with a 6b. All right, and on the top, I'm going to kind of jump ahead so it's easier to draw my picture. Is going to have a b across the top. So I already know I'm going to have a b across the top. And now I'm going to have 6 b's going down. So that just helps me drawing my box. So I'm going to have 1, 2, and they should be the same size, but again, I'm not an artist. 4, 5, 6. And all of these would be then b squared, because I'm multiplying b times b to get the area of these little squares. And so there's my 6b squared. And then plus 3, so I'm going to have 1, 2, 3. Each one of these is 1. So this whole side here is 6b, which is right there. This whole side is b plus 3, which is right there. And when you multiply those together, we get this. Or if you go through and look at each box, this is these little rectangles. The side length here is this b times 1. So these are going to all just be b times 1b. And there's going to be 6 rows of 3, so there's going to be 18 b's. And that actually shows me, hey, I made a mistake back here. I just put 18, but it's 18b. And I checked back to my work, and sure enough, I missed something. How come this is just 18? Because 6b times 3 is 18, and the b tags along. So by going through this little procedure here, I'm sorry if that wasn't on camera there. By going through this little procedure, I noticed a mistake here in my multiplication. So you can see that this is helpful. Okay, on to the back real quick. Now they're giving you the picture, and we're going to go ahead and translate out of it now. So we're going to express the area of the sum of the smaller areas. So adding these up, not doing multiplication. Sum, adding. So each one of these would be an x squared. So I already know I'm going to have a 3x squared. And each one of these is going to be a 1 times the height, which is x. So it's going to be x, x, x. 3 x's, so plus 3x. All right. Now express the area as length times width. So this is x, and this is 3x plus 3. So length times width, I would be multiplying these together. It would be x times 3x plus 3. And you can double check yourself here. I would multiply and get 3x squared. I would multiply and get 3x. These should be equivalent to each other. And then what equality is showing? It's showing you that these equal each other. 3x squared plus 3x equals x times 3x plus 3. That's what this exercise is showing you. All right, real quick here. Each one of these is an x squared. So I have a 6x squared. Each one of these is an x. All right, and there's 8 of those, so that is plus 8x. If I was multiplying length times width, this is 2x. This is 3x plus 4. So it would be 2x times 3x plus 4. Double check yourself. Multiply this times this. I do get 6x squared. Multiply this times this. I do get 8x. If they're equivalent, I know I did this right. And so I've proven that these are equal to each other. That's what they're asking for on this last line. Okay, and 17. These are all x squareds. And these are all x's. You start to get the hang of this. It's a little different at first, a little different way of thinking about it. So this is x plus 3. This is 3x. So adding them up, that's 3x squared. And then I've got 9 x's. And multiplying, this is 3x times x plus 3. And just so you know, you can write it the other way around. You can write x plus 3 times 3x. That's fine. And double check yourself. 3x times x is 3x squared. 3x times 3 is 9x. So I've proven that these are equal. And that's what we're going to write on the last line, that these equal each other.